Welcome back. I think the picture says it all. Let's find out. This video is sponsored by PCBWay, the one-stop shop for PCBs, assembled PCBs, 3D printing and much more. Call by their website and have a look today. I've been to another radio rally, and what did we get this time? We got a HeathKit Daystorm resistor and caps meter. So it measures capacitance, resistance and leakage up to, it's got the wrong knob, but up to 450 volts. And a nice magic eye. It's in pretty good condition. I'll take off the price tag, that cost me 15 quid. So let's see if we can get in and have a look at the inside. Sorry about the noise. Alright, turn it over. What have we got this side? We have 2 screws. I'm assuming you get in through the back, but I'm not sure. We'll undo the screws. And then I suppose it's a matter they're not very long screws, so they didn't go in very far. But how do we get the back off? It's in such good condition, I don't want to use my normal method, which is the screwdriver, but we'll try once. No, that didn't even seem to move it. Nope. So I don't know how we're going to get into here. You can see we're trying through there. Oh, nope. What about rubber feet? No, they're just pushed into holes. There's no screws behind them. It must just pop off somehow. Well, that wasn't good, was it? Not sure if it will focus in on that, but there is now a bit of my screwdriver stuck in there. So that wasn't a good move. It's just enough screwdriver bit left. Yeah, I'll bring it in here. There's just enough left that I can probably get away with grinding that back and grinding a new face on it. But that doesn't help, because it didn't actually get me anywhere. Maybe I need a bigger screwdriver. Can we get a bigger screwdriver in? It's damaging the box. Let's pull it out. Oh, okay. front's coming loose. Surely that's not, the front shouldn't be held on by them screws, surely. And the answer is yes. No, that I didn't expect. To tell you the truth, I was expecting to get the back off. So there we have it. It looks in very nice condition. If the transformer's gone, God knows where you get a new one of them. Oh, it's got a lovely smell. God, that is a serious resistor. 2 microfarad polyester. If we zoom in, see how clean this is. I don't know how well polyesters last. But we have an 8 microfarad 500 volt. I expect they're going to come out. We have a 0.1 microfarad 600 volt. I think you can see that there. 0.1. Is it focusing on that? 600 volt DC. It's a rather weird, squeaky pot. We have the this is the capacitor leakage test switch. As you see, it's got quite a spring pulling it back. And what's on here? An EM34 Mullard I-tube. So, not a lot in here, but somewhere in here is a selenium rectifier. I'm not exactly sure where that's going to be. Transformer's looking good, unless that is it. Could that be a high voltage selenium rectifier? K8/25. Whoops, you can't see that. So, we'll look it up. Is that the selenium rectifier? I think the American versions of this had a bulb. Oh, yep. I just looked. Not sure if you can see it there. I did print off a diagram and I circled what I thought would need to be changed. And there's the 2 8 microfarad capacitors and the selenium rectifier. They said here it's a K8/25, and if you look there it says K8 and then /25. So that is the high voltage selenium rectifier, and I'll put up a picture of this and maybe we can discuss it. Yeah, so that might get replaced. The click, we'll spray some cleaner and stuff on the knobs, but it's in a lovely clean condition and it has quite a nice vintagey smell. But looking at this, someone has been in, and that's a new mains cable. So we wouldn't have had, I don't think we had blue and brown for live and neutral when this was made. It might have been red and black, and we probably didn't have the yellow and green earth. So this has been looked after, and someone has changed out the mains cable. But even though it's a HeathKit, I think this was made in England, so it's not actually a kit. It's a production built unit. So hopefully conditions of the soldering should be a lot better. But you know, I shall check that, and if that's not okay, if the selenium rectifier is okay, I shall leave it in. But the electrolytics will definitely go, and probably that one, just in case. What's up here looks like it could be okay. I'm not brilliant in the vintage stuff, but I think it's okay. So we'll get the capacitors order, and before you know it, we'll be fitting the capacitors. Right, here we are, back on the unit. The caps have arrived. You can notice the difference in size. Tiny. So first things first, I'm going to find a pen, and I have a small, I thought I had a smaller Sharpie somewhere. So what we're going to do is plus there, minus there, minus there, plus there, so I can remember. I'll rub it off afterwards, I expect. Now what I'm going to do, I think, is I'm going to take these caps out, and I'm going to put the little ones to the ground pin and then run a wire back. That's my plan. And to do that, I'm going to use my big Bertha iron, which is here, and it's a, well, you can't really see it anymore, it's a 60 watt Weller, and the tip on here has got to be 30 years old. The lead's not very long, so hopefully it's gonna be awkward out to get it in. That should have enough thermal mass. Oh, would you believe it? Ah! It's gonna, what's it? Stuck! Oh. That took up a lot of solder in that push. Come on, let's get some more. Oops, I want to melt the wires on there. A little bit of solder to help. I know what I'm going to do, make life easier. I think if we get this working, we might actually test the caps with it, see if they leak. I could just undo that nut, I suppose, and I just, oops. Things are falling on the floor. Hey. There we go. Need to find the oh dear. Ooh. Now my solder sucker's stopped. I'll have to pause. Look, it's jammed. Actually, what I'll do is oh, shouldn't really do that. And then take that in the bin. Push it back out. You can see all the stuck solder in there. The solder that's in here. Back out. You can just about, no, you can't see it. The solder is stuck. Oh, I had to do it off screen because it was too awkward, but there it is. Big splodge of solder. And later on, I'll empty all that out with a pair of wires. But then that must add to the mass when you no, wrong iron. using this one, the big one. Right, 2 holes. Right, so I'm going to have one capacitor sitting there with the positive going to there, and the other capacitor. Now what I should do is, really, when you bend the wires, is you should bend them around something, because you don't really want to put force on that seal. If you can see it there, you don't really want to put pulling force on that if you can get away with it. So put a bend on there, and we'll put a bend on there. I think we will tidy that up. That will shrink back, I expect, when we solder it. Which it has done. Now, sometimes it's worth tinning a wire like that to get the insulation to shrink back, so that when you put it on and do the joint, the insulation, you could, it shouldn't shrink back anymore. So I've done that on equipment where you need a tiny piece of copper exposed. You expose some, tin it, the insulation shrinks back. Then you cut it to the length that you need to go inside the little connector or so, and then when you solder it in, because the insulation has already relaxed due to the heat, it doesn't normally relax back any further. So that helps in, you know, not having too much wire exposed out of the back of a small connector. Because what you don't want is lots of, you know, bare wire sticking out of your joint. It's not good for the joint. So that can go into there. Not sure I'll clamp it down. That should do. A bit of solder. Right. Oh. That looks okay. Maybe I'll put a dob of hot snot down there at some point. Alright, what are we going to do next? We have, what is this? 24 gauge tin copper wire. I'll find the end. And you can see it's all wiggly woggly, but we'll just grab hold of that. And we will pull. And now it's all nice and straight. And my plan is here, hopefully this is a good enough diameter. This is PTFE sleeving. It fits down there nicely. So the plan now is to solder that onto there and run it down to there. So for that I need some heat shrink, so I'll be back in a second. Right, back. So using some round nose pliers, which are also, I was given these for the first company I worked at in 1976, so I've had them a long time. And the iron under my arm is getting very hot, and I'll just put a loop. It's very cack-handed the way I've got the, I'm going to move that iron because it's getting my arm very hot above it. I might need to, oops. And I want to put a loop in there. The idea being is that I'm going to have a mechanical joint. That'll do. So it's got a much more better joint than just laying the wires together. I don't like laying wires together. So one nice-ish soldered joint, and then hopefully cut the end of that. Piece of heat shrink tubing. It don't want to go. It's slightly a little bit too big. Let's hold on to that. Push with ease. There it goes. And then a bit of oops, doesn't help. I'm balancing it on a solder pot. Oh, that's no good. I'm now flooding. I need to find something else to balance it on. My cup. So now I can trim that to there, pull it back. She'll probably speed all this up. Push that back inside the heat shrink, and that's just got to go on there now. So I need to take that capacitor off. Just speed this up, I think. Yeah, got a hole there. So that's one done. Try and close it. Oh, that'll do. Right, well, that's that one done. So now, do the same. Trim that. Right, I really should have put those in so that you could see the values, but nope, can't be bothered. And we'll just shrink down the ends with the iron. Right, hopefully they won't go bang. Right, we're back for the first electrical test. Now you've got to remember that when the switch is plugged in, this becomes live on the top. It's a bit of a bad design. There's various parts of it are live. I'll just pop up the picture so you can see on the screen what the circuit looks like. But now we've put the caps in, we might as well have a look and see what voltage we're getting. So there's an earth point there, and I'll put it onto this one and we'll turn it on. That's slowly creeping up, which isn't very high. We'll turn it off. It's not as high as what the diagram says. Turn it off. We'll put it onto that one. Turn it on. Now that's very weird. Look at it. Plummeting away. So there's something definitely wrong. So what can it be? I think we'll need to pull up the circuit diagram and look at that. Alright, here we have a circuit diagram pulled up. These are the two capacitors in question. And on the American version it has a valve, a discrete rectifier valve, and on the UK version, that was especially the one that was manufactured as a complete unit, the Daystorm or Daystrom one, it has a selenium rectifier. If I move the circuit over a bit, there it is. That's the selenium rectifier. So as you can see here, we're looking for 150 volts. Expand that a bit. So you can see there, we're looking for 150 volts positive with respect to ground here, and minus 410 with respect to ground as well. Now 410 is going to be very close to my 450 volt capacitors, but that's 410 volts DC. I'm going to have to look at the capacitor, and I expect that's a 450 volt DC as well. So it'd be nice if it was a 450 volt AC, but it is not going to be. Right, so that's our problem, you say. Here we go, we've zoomed in. So, nice hole there, and a reasonable hole there. So, black one end, red the other. And funny plastic inserts. So, what happens if we get a scalpel and go through this one. And does this. Oh, it pulls out. So what happens? Oh, that comes out as well. Don't know where I put the first one. Must be around somewhere. There it is. So what does that hold in? Oh! It holds that. And what has fallen out? 1, 2, and a spring. All right. A very dirty spring. If that's meant to be making connection, that's pretty dirty. these are the stacks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, hang on. 6, 7, 8, 9, 10. Well, there's 10. Oh. 2, 2, 4, 6, 7, 8, 9, 10. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then whatever that is. Is that a stack or just a blob of metal? That looks like a blob of metal. Right. I couldn't find any real information on that. Apart from it was an STC and it's a K8/25. Now, I wonder if the 25 denotes the volt drop across it, because there are 26 of these segments, and people say that the volt drop across each of these diode sections is about a volt. So when it's running, this will be about 25, 26 volts. So does that actually correspond with the 25 there? So what I want to do now, I could just put a diode in there and a resistor to drop 26 volts at whatever the current is, or there is a channel, I'll have to look it up, I'll insert it up here. There is a channel that has made an electronic rectifier and dropper to replace these. So that's the decision. Do I just put a diode and a resistor in here and make it look proper and normal, or do I go with an electronic one? I'm tempted to put, I might try, maybe I'll look at his circuit. Can I get his circuit in here? That'd be interesting, wouldn't it? Well, that's where I'm going to have to leave this part 1, I think, while I sort out what I'm going to do with the rectifier situation. Anyway, if you like what you see, hit the subscribe button, click on the like button, click on the notification bell, and I'll catch you on the next one.